Okay, in this video we are going to go ahead and pick up with our Unit 4 review on polynomials with factoring. So question 9 in our review packet says we have to factor the following polynomials. It reminds us to check for a GCF first and then identify the number of terms to proceed. So remember, if I see 2 terms, it's probably a special case. If I see 3 terms, it's probably a T-chart. If I see 4 terms, I probably have to do grouping. So let's take a look here and see if that's true. Our first problem, example A, has 2x cubed plus x squared minus 3x. And right off the bat, I see a GCF. Every single term here has an x in it, so my first job is going to be to factor out the x that all 3 of these terms have in common. I'm going to write down what's left over once I've removed that extra x. So 2x cubed divided by x is just 2x squared. X squared divided by x is just x, and negative 3x divided by x is just negative 3. Now, inside the parentheses, this is the quadratic that I have left over. It is 3 terms with no more GCF, and I can use a T-chart to factor it. Now, the T-chart method I'm going to use for this is fake factoring, because I have an A value out here that's not the number 1. I've got to use that 2 when I factor. So for my T-chart, I need to find 2 things that multiply to A times C. So A is 2, C is negative 3. I have to find 2 things that multiply to negative 6. Multiply to negative 6. These numbers I find will have to add to the number in the middle, which is an invisible positive 1. So the factors of 6 that I can use are 2 and 3, and if I want to get a positive 1 when I add them, because they have to be opposite signs to give me this negative 6, I've got to have a positive 3 and a negative 2. So my larger number is positive, it will give me a positive sum. Now I'm going to go ahead and put those 2 numbers I just discovered into parentheses with AX, and this is why it's wrong. My A value is 2, so I'm going to put 2x in both parentheses. I'm going to use the negative 2 and the positive 3 for my factors. It doesn't matter the order that I put them in. And I'm going to go ahead and bring down this little x to make sure I don't forget about it. Now this is almost finished, except I put an extra 2 in here because I'm doing fake factoring. So my last step to finish factoring is to take this extra 2 back out. When I did A times C, I ended up with an extra A inside both of my parentheses. So I have to divide one of these by one factor of 2 and the other one by the other factor of 2 to remove it. So the factors of 2 are 2 and 1. This side, the left, can be evenly divided by 2. The right side can be divided by 1. So I'm going to go ahead and do that to make sure that I have removed the extra 2. So my x, again, will just come down to be part of my final answer. 2x minus 2 divided by 2. The 2x divided by 2 is just x. The negative 2 divided by 2 is just minus 1, like that. And then the 2x plus 3 divided by 1 won't change. 2x plus 3. And now that's completely factored. Let's go ahead and take a look at example B to see how we can factor this guy. We have 5n cubed minus 10n squared plus 3n minus 6, and we do not have a GCF for the entire thing, and it has 4 terms. So that tells me that grouping might just work. So I'll group the first 2 terms together and the second 2 terms together, and I'm going to take out the GCF for each term. So the GCF for 5n cubed and negative 10n squared is 5n squared. And I'll write down what's left over once it's been removed. 5n cubed, after I remove 5n squared, is just n. And negative 10n squared, when I divide away 5n squared, is negative 2. There we go. For my next term, I have a 3 in common, a positive 3. And if I divide away 3, I have n minus 2 again. And since these match, that tells me that factoring by grouping has worked. And I'm going to go ahead and do the next step, which is to factor out my GCF one more time. And that means bringing that n minus 2 to the front. And then the 5n squared and the plus 3 end up in their own factor together. 5n squared plus 3 cannot be factored any further, which means that is finished. All right. The reason that I know it can't be factored any further is because it's only 2 terms, but it's not perfect squares or perfect cubes, which means it's done. Down here, for example C, I have a 2-term polynomial with no GCF, which means it's probably a special case. And the clue that I have for this one is the exponent 3. That tells me B is being cubed, so there's a very good chance that 125 is something cubed. And it is. It's 5 cubed. 5 times 5 times 5. So I have b cubed and 5 cubed, which means this is a difference of cubes. And in order to factor it, I have to remember 2 things. I have to remember the pattern, and I'm going to write it down here. The pattern is A, B, A squared, AB, B squared. And I have to remember SOAP, which stands for same, opposite, always positive. So this sign will be the same as my original, this will be opposite, and this is always positive. So let's go ahead and use this pattern to factor this perfect cube. My A value will be the number 5, my B value will be the letter B. So let's go ahead and fill in the pattern here, A, B, so it's going to be 5B. And in here, I'm going to have A squared, so that's 5 squared, AB, so it's going to be 5B, and B squared, which is going to be B squared. Now we can do our signs. The signs start with the same sign, negative, the opposite sign, positive, and the last one's always positive. Now the very last thing I can do is just simplify this a tiny bit. I actually know what 5 squared is, so my final answer is going to be 5 minus B times 25 plus 5B plus B squared. And that is finished being factored. I can't factor anymore. The second trinomial here, 25 plus 5B plus B squared, is not factorable. So that one's all done. Let's go ahead and take a look at example D. For example D, I have no GCF. And again, I have two terms, and the clue here is that 36 is a perfect square, x squared is a perfect square, and so is 49. So I can figure out what's being squared in each case, just like I did for my cubes. 36x squared is what I get when I take 6 and x and square them. So my first term, a, is going to be 6x. 49 is what I get when I take 7 and square it. So my b term is going to be 7. Now, this looks like a difference of squares, but I have a plus in the middle here. As soon as I see a plus in the middle, I know I'm going to have to add I to my factors. So this 49 is actually going to give me 7I. And that's, let's finish factoring it, and then I'll show you why if you want to watch. So the pattern I'm going to use now that I know it's got I in it is exactly like difference of squares. So I take my 6x from the front, and I put it in the front. I take my 7I from the back and put it in the back. And I finish my factoring with 1 plus, 1 minus, and I'm done. Now the reason this is imaginary, let me segue to remind you, and you can stop here if you already understand this part, is because in order to factor this in this way, I have to make 36x squared plus 49 into a difference of squares problem. So I have to rewrite the plus in the middle to be a minus instead. But I can't change the proportion of this question. So I have to do 36x squared minus something that when simplified is the same thing as adding 45. And the way that I can do that is by subtracting a negative, 49. Subtracting a negative 49, because when I do minus a negative, it's the same thing as saying plus a positive. So if I take this plus and break it up into a minus and negative, and then go look for my squares, I can see that the square root of 36x squared is 6x, but the square root of 49, negative 49, is 7I. The square root of that negative is what gives me the I. So if I do 7I squared, then I get the negative 49. And if I put it back into my difference pattern, that's where that plus comes from. The easiest way, again, to remember it is if you see a plus sign in what should be a difference of squares, you just have to add an I to the last term. The rest of it works exactly like factoring difference of squares. All right, this problem's all done, so we're going to pick up with a little bit of graphing in the next video.